Hello everyone, welcome to our learning series of how to use Unreal Engine for architectural visualization. In this video, we're going to continue in our widget slide designs, but more specifically, we're going to create a VR bound to be available in our widget to switch between the Arch-viz character to the VR bound that we're going to create in this video. So to start, we're going to create a button, and this is going to be basically showing a representation of the, let's say for example, the character, which is the VR Arch-viz character, as a human walking around the scene. So we're gonna browse for this and apply this, and hover and the pressed image. Another button we're gonna create, which is gonna present also the VR. I have imported a small image that represent a representation of the VR headset, so it can be more clear for whoever gonna see this to activate it. So I'm gonna browse for this and also apply it in the hover and also in the pressed. Okay, so now that we have our two bounds available in our widget, before we start creating blueprints to how to switch between them, first we're gonna need to create our VR bound inside our level here. So to create a VR bound, there are many ways to do this. One of the easiest way is to go to the add new and add feature or content back of the epic. So if you want to create a very fast way to create a VR bound, you can basically add a virtual reality back to your project, and you can just drag the locomotion or the motion controller bound to your level and to your scene and start teleporting immediately with your VR headset. But we want to learn how to create a VR bound from scratch, because it will help us understand how the process go through the blueprint, and if you're facing any problems, however, if you're using this or the custom VR that you're going to create, in case of any errors or any problems, you will know how to go through the blueprints. So to start, we're going to create a bound, and why we are creating a bound, not an Arch-viz character, comparing to what we did before. Basically, the bound will be representing the height of the headset inside the level, because we want to make this connected to the VR headset level. It should be just a simple bound without any height representation for the camera, as we have done for the Arch-viz character. So basically a VR bound, that's gonna be enough for now. Okay, and double click it, and we're gonna create a camera, and then we're gonna create a motion controller. So in our case here, make sure that the motion controller is not attached to the camera. In our example here, we're gonna use the Oculus Rift as our VR representation. It's okay, I mean, it's the same thing if you're using the HTC Vive or the Oculus Rift or any of the new models of these two. The same way we're gonna create this will apply to all the different VR headsets. Which is better and which is recommended? I believe there's lots of videos out there showing the ups and downs of each of the headset, but eventually they all do the same job, and they all have a great presentation of the virtual reality. Okay, so for the motion controller for the Oculus Rift, we're gonna go and enable the display model of the Oculus. So if you just zoom in, we have our motion controller, and this is the left one. So make sure to name this as the left, and Control W to duplicate it, and name this as the right, and make sure here that you enable a right one. So both are in front of the camera, and as we can see, they all represent the same the direction of the left and the right. Okay, for the HTC Vive, I believe after you guys install the Steam, you'll find the models available in the program files, where you can import them inside the Unreal Engine and also drag the material for them. Okay, so now we have the camera and the motion controller. We're gonna need a cylinder or a static mesh, for example, to enable the teleport through this static mesh. So first let me drag a basic cylinder shape, which I have here available. I'm just gonna decrease the size of this one. So let's make it 0.5 or maybe 0.75, 0.75. Sorry. And maybe decrease the scale a little bit, somewhere around here. It's okay. I mean, it's just a representation of the teleportation mesh. So I'm gonna name this teleport. Let's say cylinder. Okay, so why we're gonna use a teleportation method instead of walking as the same way we are doing with the Arch-viz character? You can use movements inside the VR virtual reality experience, and it's really awesome for those who are familiar or who doesn't have motion sickness from the virtual reality experience. But if you, for example, gonna present this for your, let's say for your clients, and some of the people who are gonna see this presentation might not have the same, let's say for example, the same level of experience with the VR movements, they're gonna have a motion sickness definitely after, let's say for example, 20 seconds or 30 seconds, and they gonna definitely say we cannot actually continue the walkthrough because of the motion sickness. So if you're doing an Arch-viz project, I believe from all of our experience in this field, the teleportation is the best method to use in case of VR movement inside the project. Okay, so now we have our camera and now the motion controller and the cylinder teleportation method, or the node, or the static mesh that we're gonna use. We're gonna go to the event graph, and because we are using an Oculus Rift, we're gonna need to set up the origin for this Oculus. So I'm gonna call set origin track and make sure it's on the float level. Okay, so if we drag now our VR bound into our scene, sorry, let's just put it here, around here, and we're gonna go to the Arch-viz character, and we're gonna disable actually the auto persist from this one here, auto persist player. Let's make it disable, and for the VR bound, let's make it player 0. You can go also in the world setting and change the bound to VR bound. Okay, so before we do that, before putting the headset, I'm gonna go to the editor preference, I guess, and in the play section, we're gonna make the resolutions for you guys to see the presentation in full screen. I'm gonna adjust it to my monitor size, so I'm guessing around let's say 27 is fine, but I just need to set up the same resolution of my monitor. Okay, so this should be fine for now. Okay, so before starting, we're gonna need to disable our widget presentation. As you all know, when we play we see the widget, and because this is a VR, we still haven't set up how the VR will work through the widget. We need to disable the widget for now so we can have a clean preview of our scene. Okay, so let's hit the preview button and yes, play in the editor. I'm gonna put the headset now, so I'm gonna put the controllers in my hand. So as you can see now, here's the presentation. We're gonna need to set up no collision for the motion controller, I guess. Sorry about that. So I'm gonna go to the bone and I'm gonna choose no collision for them, and for the left also no collision. And let's try this again. So putting the headset. And now, as you can see, I can see both of the motion controller, the right side and the left side. And I can see over there the cylinder, which we can adjust its height and how it looks like in RC. So the next thing is that we need to adjust how we're gonna teleport on these motion controller with these motion controller in RC. Okay. So now that we have our camera and the motion controller and the teleportation representation by the cylinder, let's start by creating our blueprints. So we're gonna need two functions. Basically, the first one is gonna be trace. Let's call it trace teleport destination. And this is basically will represent the trace that's gonna happen once the cylinder once we start tracing the cylinder inside our scene, which we're gonna do through a motion controller. And the next one is gonna be teleport to location. Okay, so inside the trace teleport to destination, we're gonna need to create two inputs. The first one is gonna represent the location of the character itself, which is the VR palm, and this is gonna be represented by a vector. And the next one also will be a vector, and this is gonna be representing the forward vector, which is the direction of the VR pawn itself. Next, we're gonna drag from the function and call a node called line trace for object. And there's a lots of different kind of the line trace actually inside the graph. This is specifically useful if you wanna do this for an object, in our case, which is the cylinder. Okay, so for the forward vector, our location will be, the location will be our start point, which is the location of the bone itself in the scene. And for the forward vector, we're gonna multiply by a float, and this is gonna represent the value that we can teleport from this location to the next. So I'm gonna put a value, let's say for example by 10,000, and we're gonna add this value to a vector. So we're gonna add this to our location and hook this to the end. So this will represent our end location. And for the object type, I'm gonna make an array. And this is to enable that the line trace will only work on the world static objects. So it will avoid any dynamic objects such as the trees or any kind of a dynamic object inside. So next, we're gonna need this line trace. Once it hit, we're gonna break this hit, and we're gonna need to drag from this the location. But first, we're gonna need to create two variables. The first one will be teleport location, and this is gonna be a vector representing the location that we're gonna teleport to. And the next one will be can teleport, for example, which gonna be a boolean, and this is gonna basically represent a condition if we can teleport or not. So I'm gonna drag them inside the graph and choose set these variables, and we're gonna connect a line trace to the variable can teleport, so it will represent the condition. So if this condition applies to the teleportation, then we can teleport to the location that we gonna find inside the location and the teleport location represented by the line trace. For the condition, we're gonna drag from the impact normal a dot. So we need to set up what exactly the conditions that we can teleport to. So from this, I'm gonna drag, make a vector. So this is gonna represent the x and y, z. We're gonna need to set up the z axis to value of 1. and for the other side we're gonna drag a bigger or equal float value, and this is gonna represent that if our trace location meet these conditions, then we can teleport. Then we're gonna drag from the teleport location, set world location, and this, sorry, set world location for the teleport cylinder. So now if the trace condition have been met, this cylinder, which represent our teleportation node or object, will be visible at this location that will be set up by our next function, which is teleport to location. So we're gonna drag from the teleport location, set actor location, and this is basically the location where our actor will teleport to. So I'm gonna drag the right motion controller, and I'm gonna get world location. So this is the location of the motion control at the time before the teleportation, and for the function of the teleport to location, we're gonna add an input which is gonna represent the location as a vector, and we're gonna add a vector for this location of the motion controller. I'm gonna split this so we can get the X and Y, only the X and Y for this motion control location, because we don't want to have the Z at the time of the teleportation. So we're gonna connect this to our new location, and by now we have finished our function, and we're gonna move to the event graph, and we're gonna go to the event tech. We're not gonna need the actor begin overlap. So from the event tech, we're gonna call our trace teleport function that we just created, and we're gonna need our right motion controller and get the world location, and we're gonna get vector forward vector, sorry, and we're gonna connect this to the location. This is for the forward vector, and this is for the location. And finally, to achieve this teleportation, we're gonna need to have an action that we have to set up inside our project setting. So if we go to our input, we're gonna need to set up an action mapping. Let's call it, for example, teleport, and we're gonna look for an Oculus. Let's say for the right one, I think I'm gonna take, okay, the right Arch-viz, that's fine. Okay, so now I'm gonna call this action teleport. So I'm gonna find it somewhere here, and the action, yeah, here it is. So we have our action, the teleport. We need to get a branch that's to set up another condition that if we can teleport, then we're gonna call this function that we have set up, teleport to location, and we're gonna get our teleport to location here, over here. Okay, so if we compile now, let's have a test. Okay, so let's see now. If I grab the motion controller, so it seems like I can teleport, but the problem is the cylinder is not moving to the new location before we teleport. So I'm gonna check where was the mistake that caused this error. So I'm gonna check the trace teleport function destination, more specifically for the cylinder. So this is the mistake. We call the world offset instead of the world location. So I'm gonna call set world location and set world location for the cylinder. So this is basically the cylinder should move to this new location and activate the teleport, and hopefully this will do it. Okay, so let's do a test again, see if this is okay now. So here are my motion controller, and yeah, so the motion controller is determining where should the cylinder be so we can teleport to. Okay, so this is the basic idea of how to set up a teleportation using the teleportation method. And in the next video we're gonna see how we can actually switch between the Arch-viz character to the VR pawn, so we can have both of them enabled in our presentation. So hopefully this video explained how to set up the basic teleportation idea for a VR pawn. And if you have any question regarding anything regarding the teleportation or the virtual reality idea, please write it down in the comments below, and see you in the next video. Thank you very much.